Okay, I'd like to do a sample problem now. This one is fairly similar to one you'll be doing in your homework. It asks, determine the temperature at which the root mean squared speed of CO2 is equal to that of O2 at 310 Kelvin. So therefore, the first step is going to be to calculate the root mean squared speed of O2 at that temperature. So we look up the root mean squared speed formula, 3RT over m to the 1/2 power. We know that T is 310 Kelvin, and the molar mass of O2 is equal to 16.00 grams per mole times 2, which is, of course, 32 grams per mole. Watch out, here is the first place where you could really screw up. We need to deal with masses in kilograms for problems like this. So to convert to kilograms, this becomes 0.03200 kilograms per mole. All right, so now we just plug it right in. VRMS is going to equal to 3 times 8.314 joules per mole Kelvin. We need to use that R because that's the R that has joules in it. 310 Kelvin divided by the molar mass, 0.03200 kilograms per mole. And this is all to the 1/2 power. And then when we plug and chug it all the way through, it can be helpful to remember that 1 joule is equal to 1 kilogram meter squared second squared. And so that's going to cancel out the kilograms, and then the kelvins cancel out, the moles cancel out as well. So then you're left with meter squared over second squared. And then when you get the square root of that, you're left with units of meters per second. And so the answer is 491.6 meters per second as the root mean squared speed of the O2. Okay. Next, we need to calculate at what temperature will CO2 have the same root mean squared as that. And so this time, we're going to plug in the RMS value and set up an algebraic expression. R stays the same, but the unknown now is T, and we need to figure out what are we going to plug in for mass. So let's do the mass of CO2 now. That's, of course, just 2 times 16.00 plus 12.01. And then when this is in grams per mole, so then when we convert to kilograms, this should be 0.04401 kilograms per mole. All right, let's put that in here, 0.04401 kilograms per mole, and to the 1/2. So we're going to, in order to solve for T, square both sides of the equation, and then just plug and chug the algebra. And the temperature that we get is 426.4 Kelvin. So this means that we would have to get CO2 this hot in order for it to have the same root mean squared velocity as O2 did. And that's our final answer.